Okay, we continue, student. Okay, example to transform the following to sinusoid. You have 7 cos. The equation is Vt 7 cos 2t plus 40 degrees. Okay, transform to phasor directly. You get the amplitude as your magnitude and the angle, the phase difference as your phasor angle. Right. The next example is Vt 120 sine. Okay, the sine in equation in bracket tan t minus 50 degrees. Okay, here sine, you must do the conversion to cos first, then convert to polar form. Okay, how to transform from sine to cosine? Okay, you can get from the trigonometric identities from the previous in chapter 1.1 and 1.2. Okay, you just get, okay, what is the value of, okay, here for example positive, right? The sign, okay, the sign is positive, so you can use, okay, for the sign positive, you can use the cos is in negative. Okay, the subtraction of the degrees negative. If the sign is negative, okay, you can use the plus here. Okay, but now the sign is in positive. Okay, the amplitude is positive, so you minus here. All right, so from the equation 120 cos in bracket tan t, okay, minus 50 degrees, okay, the reference here, so you subtract which minus 90 degrees. Okay, you get the new value of your phase difference and already do the conversion in cosine, and then you can transform to phasor. All right, so 120, the angle is minus 140 degrees of voltage. All right, or you can directly, okay, by using your table 1, okay, in this chapter, okay, just subtract with 90 degrees. Okay, also you can get the answer directly. Okay, number 4, okay, minus 60 degrees cos the angle is 30t plus 10 degrees. All right, in milliampere. This one is a instantaneous equation, or we call it steady state, we call it time domain. Okay, you have 3 names, okay, to represent the sinusoid equation is steady state equation. All right, then we call it also time domain equation. All right, okay, now how to convert? Okay, now the amplitude, okay, is negative. Okay, you must convert this one into positive cos. Okay, how to convert? You have from the trigo also, so the trigonometry equation stress here, okay, given here, minus cos. Okay, then you do the transformation, you can do plus or minus, both can. Okay, so from 60 cos, okay, so you directly convert positive amplitude 60 cos, then bracket 30t plus 10 for the reference plus 10. You can do both plus minus 180 degrees. Your for the first is you do the addition, or the second, or you can do the subtraction. Okay, we can use both answer, okay, in your calculation for the net calculation. So transform in phasor after get the conversion of the positive amplitude in the cosine. Okay, can you convert to phasor? So you can have I, okay, I in phasor is 60, the angle is 180 degrees in milliampere, or okay, 60, the angle is minus 170 milliampere. Both answer you can use in your calculation. Okay, one thing I want to stress here is, okay, in time domain you have the equation is IT in t, okay, in time domain, but when you convert to phasor, no t, only the vector here. Okay, no t, okay, no t in bracket, only the vector of I that contain the magnitude and the angle. Okay, next example. Okay, you have minus 4 sine. Okay, you must do the conversion. You must get the positive cos. Okay, you must convert to get the positive amplitude and cos. Okay, here, okay, you have a negative sign. Okay, negative sign here, so in your angle you must do the plus here. Alright, if plus, negative lah. Okay, but here minus, okay, minus. So you must do the plus. Alright, so from the reference you have 4 sign, so you get the positive 4 sign here. The TT, okay, plus from the reference is plus 50. So now you must add first from here, right? Add first, okay, plus 90 degrees here. So you get the answer. In positive, cos 4 cos in bracket 30t plus 140. Then barulah can you convert to phasor. Okay, phasor no t, only vector value v. Okay, you can bold or do the vector value is 4. Okay, the angle is 140 degrees. Okay, note that before transform to phasor domain, again in polar form, all right, make sure the time domain is in cosine function, either it or vt, with positive amplitude. Okay, now the example here, okay, I have the equation of a negative 10. Negative 10, the angle is 30 degrees. Also, okay, when you have the polar form like this, okay, like this, in negative 10, the angle is 30 degrees. Okay, here you must focus here, the negative one. Okay, get the positive magnitude first of phasor before transform it to the time domain. Now I want to convert from the polar form to the time domain. All right, so the answer here you do also you must nila hafal or remember this equation. When you have the minus 1 here, okay, you can do the transformation by plus minus the angle. Okay, plus minus the angle, so you can get the positive here 10. All right, 30 degrees the reference here, you plus 180 degrees or you minus 180 degrees. So you can have two answer here. 10 the angle is 201 degrees or 10 the minus 150 degrees. Okay, then you transform back your answer is time domain. You get 10 cos omega t plus 210 degrees. Okay, the important thing time domain is vt here. You have the vt and you have the omega t. Never mind, you not have the frequency yet, but you just put the equation omega t. Okay, the complete of cosine or sine function lah. This one is cosine function. So the other form you can have the negative 150 degrees. So you have two answer here. So the last example here, okay, find the sinusoid of time domain represent corresponding to this phasor. Okay, when you have this phasor, okay, this means it's a vector here in j multiplied by 12 minus j5. Okay, how to convert in time domain from this rectangle? This one is the rectangular form. Use your calculator. Okay, use your calculator. Don't do it directly from your from your hint, from your feeling inside. No, just use your calculator to do this multiplication. Okay, so you put your calculator, j in bracket 12 minus j5, you get the answer in rectangular form. Then you convert to polar form, then transform back in time domain. It 13 is the magnitude, 13, okay, then time domain is the amplitude, cos omega t plus your angle in phasor as your phase difference in time domain representation. All right, so next, okay, example 4, given two equation. For V1 is minus 10 sine in bracket 10t minus 30 degrees and V2 20 cos 100t plus 45 degrees. Okay, so now calculate their sum. Okay, add these two equation. So you must put your equation first in polar form. Alright, you must convert first your equation in polar form, then barulah you tambah. Alright, so for example here you have 10 sine. You must convert for the positive magnitude, and you must convert first the sine, positive amplitude and sine. How to convert here? Okay, from the trigonometric entities here. So now you have minus, okay, minus sign, you must plus 90 degrees. Okay, so directly you can do the bipolar form also, just not the in from previous, like from previous example. So now you have in polar 10, okay, positive magnitude, then in bracket the effect only in angle. All right, you just plus 90 degrees, you get the answer for the first V1. Then V2, okay, directly you can convert 20, the angle is 45 degrees. Then you can do the addition. All right, V1 plus V2. The equation here, you just directly plus by using your calculator, then you get the answer in rectangular and you in polar form. Next, barulah you transform your equation in time domain back. All right, depends in question what's they asking you. All right, so the tips here to convert from sine to sine function to cosine function, you have a choice to do directly conversion directly by using phasor also. All right. Okay, this is a summary. Okay, so you must know the VT represent is a time domain, okay, or instantaneous or a steady state. Okay, the naming is time domain, boleh semua boleh lah. Okay, but when you do the conversion to phasor, the equation now represent as V. Okay, we call it the frequency domain, a phasor domain representation. Okay, the name. Okay, so VT is the dependent. Okay, V is not, maksudnya dia depends on the value of T. Alright, so but the phasor, no, the phasor has just own no T in equation. So VT is always a real with no complex number term. Okay, VT is a real with no complex number term. V is generally complex. Yeah, okay, complex. We have the magnitude and the phasor. Note that phasor analysis applies only when frequency is constant. It's applied in manipulating two or more sinusoidal signal only if they are of the same frequency. Remember, same frequency. All right, same frequency. The frequency is constant at the 50 Hz or 60 Hz. All right, thank you, student.